right, so we've got an interesting question here looking at positive integers n and t, and we're trying to find the greatest prime factor of the product of nt, the multiplication of these two. Now, logically, the greatest prime factor of nt is going to be the greatest prime number that was a factor of either n or t. For example, if we took 12 times, let's see, 15, the greatest prime factor of the result is going to be 5 because that's the greatest prime number that was a part of either of these two numbers. And when you multiply numbers, you don't create new prime numbers. You're going to end up with all the exact same factors you had originally. So while my product here, which is 180, will have larger factors like 2 and 90, for example, 90 is a larger factor than either of these two numbers had. The prime factors, if I continue to prime factor this out, I will see that the greatest prime factor was still the number 5. So you can't create a larger prime factor through multiplication. So either n or t already possesses the greatest prime factor. Now, statement 1 says the greatest common factor is 5. Okay, well, if the greatest factor that they have in common is 5, that doesn't necessarily mean that either of them doesn't have greater factors. For example, if n was equal to 5 times 17 and t was equal to 5 times 23, the greatest prime factor would be 23 when we multiply the two of them, but the greatest factor that they have in common is 5. So this isn't showing us much information about the other factors involved in n and t, and for that reason, it's not going to help us to find the greatest factor of n times t. So this is insufficient. Statement 2 on its own says the least common multiple of n and t is 105. Now, the least common multiple is solved by taking the factors that make up both numbers and taking the largest exponent attached to those factors and multiplying them together to get a final product. For example, let's do a simple analysis. If we did 24 and 36, the greatest common multiple of these two numbers would be, let's just break this down real quick, 2 cubed times 3 to the 1 is 24, and 3 squared times 2 squared is 36. The greatest common multiple is going to be 2 cubed, or the least common multiple is going to be 2 cubed times 3 squared. We have to have every prime factor that occurred in either of the two numbers, and we want the largest exponent that appears attached to those prime factors. So we don't care about the 1 and we don't care about the 2 attached to the 2 and the 3. We only want the largest factors. So that gives me 2 cubed, which is 8 times 9 equals 72. And that is the least common multiple of 36 and 24. That's 3 times 24, and that's 2 times 36. So that's how least common multiple works. And what you'll notice is if we factored out 72, we would get that 2 cubed, 3 squared. These are factors that were involved in the two numbers we had originally, though not both of them in the same number necessarily, but they are factors from the original numbers. So the largest factor of 105, which is 7, is also going to be the largest factor of either n or t. I don't know which one it came from, but it definitely came from one of them, and it has to be the largest factor of either of them. If we grabbed all the prime factors associated with n and t and then multiplied them to get the least common multiple, which is how we just showed that we achieved that using 24 and 36. So because of that, I know from statement 2 that 7 is the greatest prime factor of n times t, and that means that our answer here is B. Statement 2 alone is sufficient.